One more practice long division problem. Is x to the fourth minus 1 a factor of that polynomial? If it is, write that polynomial as the product of two factors. So remember, if I factor something, I can write the two factors as a multiplication problem, multiply back out, and I get exactly what I started with. So that's what they're kind of trying to get you to realize. What am I supposed to do with this problem? Set up the division. X to the fourth minus 1 divided into what? X to the fifth. Minus x minus 5. Good. You remembered that we need to have all of the terms accounted for. Any missing terms have to have a zero coefficient, and they have to be included under the division symbol so that you don't make a mistake. So now what happens? No. X to the fourth times what gives me x to the fifth? X. Where am I going to write that? Above the x, so all the way over here. X. And then what happens? Distribute. So x times x to the fourth is x to the fifth. X times negative 1 is negative x, which I write all the way over here. Draw my line. Change all your signs. And add. The x to the fifth minus x to the fifth is gone. The 5x to the fourth comes down. So does the 0x to the third plus 0x squared. This also disappears, and then the negative 5 comes down. Now what? So x to the fourth times what gives me 5x to the fourth? 5. So I'm going to write that right here. Positive 5, so plus 5. And then I distribute. 5 times x to the fourth is 5x to the fourth. 5 times negative 1 is negative 5, so I write that all the way over here. Change all your signs and add. 5x to the fourth minus 5x to the fourth is gone. I have 0x to the third, which is 0. I have 0x squared, which is 0. I have negative 5 plus 5, which is 0. So everything is gone. So in this particular problem, these guys didn't have any effect, but we don't know that they will or not. We have to include them. So is this a factor of the polynomial? Yes. So the answer is yes. And then it says if it is, write the polynomial p of x as a factor of, or as a product of two factors. So I'm going to write x minus x to the fourth minus 1 because it is a factor times x plus 5. The other factor. If I FOIL that back out, I get this polynomial right here. So that's how you do these problems. Now it's time for synthetic division. So it's a different way of doing the exact same stuff. It just looks different, but it's the same thing. Some of you will probably like this better than long division. Some people will like long division better than synthetic division. I don't know, it's just a matter of preference, I guess. So here's your process right here. It looks like a lot, but it's really not that bad once you see how it works. And like usual, I like to give you the steps right up front so that you have them and have seen them so that the steps start to make more sense as I show you an example. So the process is, first, write the coefficients of the dividend. The dividend is just what's being divided. The numerator. Write the coefficients in descending order. Write the constant of the divisor. The constant of the divisor is the denominator, and I'm talking about the number that you see. So like x minus 2, r would be that 2 that's sitting there. what we're dividing by, x minus r. You put that number in the box, but the sign of the number that goes in the box, which you'll see, is switched. Instead of minus 2, in this example, if it was x minus 2, then you would put a 2 in the box, a positive 2. You switch that sign. The reason that you do that is what you're really doing is you're finding the root of the denominator. You're taking the denominator and setting it equal to 0, and then solving for x. You wind up with x equals positive r. So what happened is the sign here changed. This number, the root, is what actually goes in the box, which you'll see. Bring the first coefficient down. So I have my numbers all written across. There's a number, a number, a number, a number, and a number. I have a box sitting here, and then my r is sitting there. The first number comes down. And I write it right there. Then, multiply the first coefficient by r. So this number right here gets multiplied by this, and I write that result right there. So now I'm sitting here. Add the product in the second coefficient. So now I add these two numbers together and I write that answer there. And then I just repeat. So repeat steps 4 and 5 until you get all the way through this division problem. So I'll add these two together, take this number, multiply it times that, write the answer there, add. Take this number, multiply it times that, add it to this number, write it there, add. Take this number, multiply it times that, write it down right there, add. Once I'm done with all of the coefficients, then the division problem itself is done. If you follow the steps correctly, then the numbers in the bottom row, these numbers that we're going to get right here, are the coefficients of your answer, the coefficients of the quotient. The exponent of the first term in the quotient is one lower than what you started with. So if I start with a 4th degree polynomial, my answer here will wind up with a 3rd degree polynomial. And the final number is the remainder. This number sitting right here would be your remainder. So if you get a 0 right here, then there is no remainder. So you would write 0, and then when you try to write your answer, you'll see, when you write your answer, there will be no remainder. But if there was like a 3 here, then you would write your answer and then plus 3 over what you divided by, just like we did with long division. Okay? It is called synthetic division for a reason. It doesn't look like division. So it's a process behind what you have to do. But it does work, and it's really nice to know how to do. We're going to be using it later on in this chapter exclusively. We'll get away from long division. So for example, use synthetic division to find this division problem. We want the answer. Now, like I said, all those steps are listed for you if you lose track of where you're at or forget what you're supposed to do. But what you need to do is, first of all, the way that this is written is the same as 2x to the third minus 13x squared plus 26x minus 24 divided by x minus 4. That is the same thing. I don't need to rewrite it like this, but I just want you to realize that that's the same thing. Okay? Now, you're going to set up your synthetic division problem. To set up a synthetic division problem, you draw the box and you draw your line. The coefficients of what you're dividing, so the numerator, what you're dividing, the coefficients go across the top. So right here, written across the top. And just like with long division, every single term has to be accounted for. So if we have a missing term, we have to include a 0 for that coefficient. We start with x to the third, and we have x squared. We have x. We have the constant. So all of the coefficients, all of the terms are there. So I'm going to write just the coefficients. That's this guy, this guy, this guy, and this guy, right across the top. 2, negative 13, 26, negative 24. Now the number that goes in the box comes from the denominator, what I'm dividing by. We see an x minus 4 there. But like I said, we're going to put that number in the box but switch the sign. Basically what's happening is I take the x minus 4 and I set it equal to 0 and I solve for x. If this is a root, or if this is a factor of my polynomial, then that means that negative 4 moved over would become x equals positive 4, which would be a 0, a root of the polynomial. This is what goes in the box. So a lot of times when people learn synthetic division, they'll say, okay, you're just going to take this number and switch the sign and put it here. And they don't really explain why. The reason why is what you're doing is you're putting the root in the box, not the factor. This is the factor. This is the root. So now the synthetic division is all set up. It's ready to go. This number comes down. You can draw a little arrow down if it helps. But that number gets rewritten below. Then I take that 2 and I multiply it times the 4 and I write it down under my next coefficient. And then I add. Negative 13 plus 8 is negative 5. And then I take the negative 5 and I multiply it times the 4. And that gives me negative 20. And then I write that down underneath the next coefficient. And then I add. 26 plus negative 20 is 6. And then I do the same thing. 6 times 4 is 24. I write that down right there, and then I add. And I get 0. This number right here would be my remainder. Since I got 0, then there is no remainder. Okay? Just like in long division, there is no remainder, so I don't write it. Now, the trick is writing the new polynomial as your answer. These are the coefficients right here of the new polynomial. It's going to start off 1 degree lower than where we started. So we started at x to the third, which means that this will be 2x squared minus 5x plus 6 with no remainder. So the answer then is 2x squared minus 5x plus 6. If they said, write it as a product of two factors, then you would write x minus 4 times 2x squared minus 5x plus 6. This is exactly what we did with long division, just without having to write out the long division. Now you don't have to chew on Tums. I put a box around it. Okay. I do want to show you, before we go on, I want to show you the long division version of this same problem. Just to show you that what we're doing is very, very similar, even though it looks different. So I'm going to have the x minus 4 outside. So I'm not looking at this right now. I have the x minus 4 outside divided into the 2x to the third minus 13x squared plus 26x minus 24. What times x gives me 2x to the third? 2x squared. Look. So that gives me 2x to the third and then minus 8x squared. I change all my signs, and what do? I add. What was I doing up here? Adding. Notice that the 2x to the third minus 2x third is gone, and then I have this negative 13x squared plus 8x squared, and I get negative 5x squared. Up here I had negative 13 plus 8, and I got negative 5. It's the exact same thing, just not written out with all these letters involved as well. So then I bring down the next thing, 26x. What times x gives me negative 5x squared? Negative 5x. And look what I have right here, the negative 5x. Distribute, and I get negative 5x squared plus 20x. I change all my signs, and I add, and I have 26x minus 20x, which is 6x. Up here, 26 minus 20, and I get that 6. Minus 24. What times x gives me 6x? Positive 6. And there's my positive 6 right there. If I finish the problem off, I have 6x minus 24. Change all my signs and add, and I get a remainder of 0. So the long division and the synthetic division are exactly the same thing. The numbers that you get in synthetic division are the same numbers, the same coefficients that you would get in your long division. It's just that long division is longer. Synthetic division keeps everything nice and compact. It'll save space and it saves time. But you have to understand what it is that you're doing when you do synthetic division for it to be effective. Okay, let's do another one. See if you can help me set this one up. What do? Draw the box, and then the line. Now what? The coefficients, the numbers in front of all the terms. Good. For 0, we're missing the cube term. The a to the third term isn't there, so I got to include a 0. And then 2, and 12. So all of the terms now are accounted for. If you don't put that 0 in there, you will get the wrong answer. It's guaranteed. You got to see that all the terms are there. We start with a to the fourth. That means I got to see a to the third, a squared, a, and the constant term. I see a to the fourth. I missed the a to the third, so I got to put a 0. I have the a squared, I have the a, I have the constant term. So just 1 0. Okay? And they have to be in the correct order, descending order. So what goes in the box? -2. It's -2 because this is the factor. I'm putting the root in the box. Okay, now what happens? Bring down the first number. It comes straight down. There's nothing to add to it. So we put the 4 there. Now what? 4 times -2 is -8. And what do I do with that? I put it here, and then I add. So I get -8. Then what? -8 times -2 is +16. I write it here, and I add, and I get 18. Then 18 times -2 is -36. So I write that down, and then I add, and I get -40. -40 times -2 is 80. So I write that down, and then I add, and I get 92. So I'm done. I didn't get 0 here, which means I have a remainder of 92. Now I need to write my answer. This is not the answer. The answer will be 4a cubed. Good? Yes? Okay. Over a plus 2. So my 9 looks like an a. 92 over a plus 2. And that is the answer. Set up the problem. Box, line. -2 in the box. Coefficients are 1. Good. What happens? Bring down the 1. Then, so -2 here, and I get -16. Then, +32, and then I get 83, and then is -166. I add those together, and I get -220. Good. The more of these you do, the faster you're going to get to the point where these problems actually happen very quickly. What does this answer mean? $220 over, that's your answer. And what? How do I go from here to here? Okay. So the rule is, if you go back to the rules that I gave you in the beginning, the answer here, these are the coefficients of your answer. And you will start, the degree of the front coefficient will be 1 lower than what you started with in the original polynomial. So instead of x to the third, this will be 1x squared. And then you go on down from there. This will be the x term, this will be the constant term, and this is the remainder. So I write 1x squared minus 16x plus 83, that's my constant term. And then since I had negative 220, I write minus 220 divided by x plus 2. All right, so let me tear through this one. Box, line, 7 in the box. Coefficients are 1, negative 57, and positive 56. 1 comes, I missed a 0? Oh, good. Good thing I'm going fast. So where's the 0 go? Right there. So the 1 comes down. 7 times 1 is 7. Add, and I get 7. 7 times 7 is 49. Add, and I get negative 8. Negative 8 times 7 is negative 56. Add, and I get 0. So my answer is x squared plus 7x minus 8. Obviously, I've done more than you have, so I'm going to go a lot faster. But that's the idea. Remember the term that was missing. Good save. Okay, so now that we know synthetic division, we can learn this new theorem called the remainder theorem. Like I said, there's lots of theorems in this chapter. This is like the second or third one right here. This is a good one, though. You're going to like it. Consider the polynomial f of x equals negative 3x squared plus 5x plus 4. Divide it by x minus 3 using synthetic division. So, okay, I set up the box. I set up my line. I have x minus 3 as my factor, so I'm going to put what in the box? 3. And then my coefficients are going to be negative 3, 5, and 4. Do synthetic division. Bring the negative 3 down. I get negative 9 here. Add, and I get negative 4. I get negative 12. Add, and I get negative 8. So I have a remainder of negative 8. Okay? Now it says, find the value of the polynomial at f of 3. So in order for me to do that, you got to think back a little bit. What does this mean? What am I going to do? Yeah, I'm going to put 3 in for x, everywhere that I see x. So I'm going to write f of 3 equals negative 3, parentheses, 3 squared, plus 5, parentheses, 3, plus 4. So that's negative 3 times 9 plus 15 plus 4. Well, negative 3 times 9 is negative 27 plus 15 plus 4. So negative 27 plus 15 is negative 12. So I have negative 12 plus 4, which is what? Negative 8. Notice anything? Yeah, and that is exactly what the remainder theorem says. I can do synthetic division if I'm asked to evaluate a polynomial at a particular number. I can take that number and put it in the box and do synthetic division. And the number I get as my remainder will be the function evaluated at that number. It's way better than trying to plug in the number into the polynomial and trying to evaluate it down. So this is an awesome theorem. And that's what it says down here. It turns out when you divide a polynomial by some factor x minus a, the remainder is the function evaluated at a. In other words, I can use synthetic division to find f of a. The remainder is my answer. F of a is simply the last number you write down after you use synthetic division, the remainder. And that's why it's called the remainder theorem. So let's use the remainder theorem and let's use regular substitution just to drive this one home a little bit. Solve by regular substitution on the left, solve by using the remainder theorem on the right. We want to find f of 4 if this is my polynomial. So I'm going to write f of 4 equals 3 times 4 to the 4th minus 2 times 4 to the 3rd plus 5 times 4 plus 2. All right, now I got to figure out what 4 to the 4th is and then multiply it times 3. What's 4 to the 4th? 4 times 4 is 16. 4 times 4 is 16. 16 times 16 is 256. And then 256 times 3. 768 minus 4 to the 3rd is what? 64 times 2 is 128. And then 5 times 4 is 20. And then plus 2. Okay, so now I need 768 minus 128. What do I get there? 640 plus 2. So I get, okay, let me write it down. 640 plus 20 plus 2. So what do I get as an answer? 662 is my answer. I don't know how long that took me. I should have timed it. It was probably like 2 minutes. All right, let's solve using the remainder theorem instead. That means I'm going to take the 4 and put it in the box. And then I'm going to write all my coefficients down. 3, negative 2. I'm missing my squared term, so 0, 5, 2. Draw my line. 3 comes down. 3 times 4 is 12. Plus negative 2 is 10. 4 times 10 is 40. Add and I get 40. Multiply and I get 160. Add and I get 165. 165 times 4. 660. Plus 2. 662. Much faster. Yeah. Just make sure you're not making mistakes as you go along. Typically when people are doing synthetic division, the place to make mistakes is with signs. Multiplying negatives and positives together. Make sure you're not making mistakes there. All right, so I'll give you guys a choice. You can either find f of 3 by substitution, or you can find f of 3 by using the remainder theorem. Which one do you want to do? Yeah. The remainder theorem. No? You want to rather do substitution? Really? Go ahead. You do substitution, and the rest of us will do the remainder theorem, and we'll see who wins. I'll even wait. All right, remainder theorem. I want to find f of 3. So I need a box and a line, and what do I put in the box? 3. Now, I will say that the tricky part is remembering that when we're doing the remainder theorem, we're finding this number right here. So that's what goes in the box. But when you're doing synthetic division, remember that you're given a factor. And it's not the factor that goes in the box, it's the root. So that's where the sign change happens. So be careful. We are not changing the sign here. We are changing the sign when we're doing synthetic division with a factor. So if you think of it as a root, then you should be okay. All right. 3, negative 6, 1, negative 11. 3 comes down, 9, 3, 9, 10, 30, 19. You beat me? Yeah, but I was blathering. All right, you want to race on the last one?
Wait, hold on. Wait, it's negative 1. We got to get ready.
Oh.
We got to think about this. Can we write it down?
Can we go now?
Can we write it down?
Yeah.
Hurry, you better hurry.
Here we go. Negative 1. And then 4. And I'm not going to talk anymore. So on this one, even though I won, I'll still go over it. We have to write down all the missing coefficients as well. We are missing the x to the 4th term, and we're missing the x term. So my coefficients are 4, 0, 2, 1, 0, negative 1. The number that I'm trying to find goes in the box. And then we do our synthetic division. We wind up with negative 6 as our answer. Last problem. The number of college students from the United States who study abroad, that means they go to some other country, can be modeled by the function that I'm giving you. I'm not going to read that. Where x is the number of years since 1993, and s of x is the number of students in thousands. Estimate the number of U.S. college students studying abroad in 2013. I want to do this using the remainder theorem. Do I plug in 2013? Remember, read the problem. It says years since 1993. So how many years since 1993 is 2013? 20. So it's 20 that I'm going to plug in. So I write 20 here. All of my coefficients in this polynomial, they're nasty looking coefficients. I still write them down. 0.02, negative 0.52, 4.03, make sure I'm not missing any, 0.09, and finally 77.54. Now I would definitely use a calculator to help me get through this as necessary, but don't rely on it. The 0.02 comes down, and then I have 0.02 times 20. So that's like 0.2 times 2. What do you get? 0.4. And I write that down, and then I add. That's going to give me a negative 0.12, I bet. Yeah? Okay. And then I multiply that times 20. It's going to give me a negative 20 times 0.12. Move the decimal over, and I have 1.2 times 2, so 2.4.
Yeah.
So negative 2.4. And then I add. I'm going to get like positive 1.57? 63? Okay, I went the wrong way. Negative 1 or positive 1.63. See? There you go. Use the calculator. And now 1.63 times 20. Move the decimal over. I get 16.3 times 2, so that's going to be 32.6.
Yep.
And I add that to 0.09. That's an easy one. 32.69. Multiply by 20. Move the decimal over and then double it. What do we get?
Wait, can you can have a remainder of students? Oh, I see what we're doing wrong.
Oh. All right, what do we get? 6 what? 653.8 exactly? Okay. And then we add and we get a total of 731.34. So that's the remainder. Now we got to put it back into the context of the problem. 731.34. The number of college students from the United States who study abroad can be modeled by the function where x is the number of years and s of x is the number of students in thousands. So we have 731.34 thousands, which means I need to write my answer as, with the decimal over 3 places, and I get 731,340 students. So always make sure you put the problem back in the context of what it is that you're talking about. And that's it for the section, long division and synthetic division. If it specifically says long division, got to see long division. If it specifically says synthetic, got to see synthetic. Otherwise, it's your choice.